In this section, we are going to look at arithmetic and geometric recursion and also explicit notation. In the warm-up, you get a new job working at the local Applebee's where the table configurations are possible. A square table seats 4 people, and 2 square tables pushed together seat 6 people. 3 square tables pushed together seat 8 people, and so on. Part A, you get a call for a party of 32 people. How many tables are needed? So I'll let you see if you can solve that. There's many different ways you can go about that. And then I can show you what I did. If you can figure that out, is this sequence arithmetic or geometric? C, can you write the recursive equation for this sequence? And D, can you write the explicit equation for this sequence? So in class we would take time to solve this and answer the following questions. And right now I'll go over how I would look at this. So I would say, all right, for one table, there's 4 people. For 2 tables, there's 6 people. For 3 tables, there's 8 people, and so on. Okay, so here we have number of tables. So I'll just put tables. And if I'm making this into a table itself, this would be the number of seats. And I would ask myself, what's the pattern? How are we getting from one to the next? And if we're looking at this, am I multiplying or adding to get to the next term? It looks like we're adding 2 every time. So if I asked if 4 tables were pushed together, that would seat 10 people. So you get a call for a party of 32 people. How many seats are needed? Well, I'm going to go back to that. First, I'm going to answer the following questions. This is arithmetic because we're adding 2 each time. So arithmetic. Write the recursive rule. Okay, so we can say u sub 1, the starting value at one table, it can seat 4 people. To find the number of seats for any table, take the table before it, u sub n minus 1, and add 2. So there's the recursive rule. You need a starting value, and you need the rule. There's a common difference. We're adding 2 every time. Let's write the explicit equation for this sequence. So we looked at that yesterday, and we know that if this is arithmetic, it's linear, and we can figure this out. Y equals mx plus b by finding the y-intercept and the starting value. So here, I'm going to say u sub n equals, and our slope is 2, and we're starting at, well, the starting value here, the y-intercept, would be if there was 0 tables. How many would that seat? So we're working backwards, subtracting 2. So if there was a 0 table, then following the pattern, that would seat 2. Okay, so here's our explicit equation. We can say y equals, or u sub n equals 2. And if I was using the n notation, it should be an n right here, 2n plus 2. And let's solve this. So a party of 32 people, how many would we need? Let's give myself a room here. So we have 32 equals 2n plus 2, where n is the number of tables. We will subtract 2. We have 2n equals 30, divide by 2. So here n equals 15. So 15 tables would give us 32 seats. And there are several ways to do this. We could also use our calculator, and we looked at this yesterday, so let's see if I can pop mine up. I wonder if it's still open here. Okay, so I'll show you how you can do it recursively on your calculator as well, and then we'll move on to the next problem. Okay, so again, several ways to figure out how many tables you would need to seat 32 people, but one way, if I go here, okay, so we know that at table 1 there's 4 people, so I'm going to hit enter. There's table 1. And then I'm going to do our last answer. So there's the recursion starting value. And we're going to add 2 every time. So there's table 1, 4 people. Table 2, 6, 3. And I'm going to keep counting until I hit 32 people. So here's 3 tables, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we can see I hit enter 15 times. So 15 tables together would seat 32 people. So you can do it on the calculator recursively as well. All right, let's look at the next problem, the zombie problem, which we've talked about first semester. We've looked at the zombies. Okay, so let's revisit that zombie outbreak situation we looked at last semester. Let's say that a single zombie infiltrated the school. The next hour there were 3 zombies. 2 hours later there were 9, and so on. Is this arithmetic or geometric? All right, so starting value there was 1 zombie. After 1 hour there were 3 zombies. After 2 hours there were 9 zombies, and so on. And so if you notice, we're not adding every time, we're multiplying, and we're multiplying by 3. So this would be 27. This is geometric. The recursive equation, so for this one right here, at time 0, so u sub 0, we would say there's 1 zombie. And for any hour, you take the hour before it and you multiply by 3. So you can either put a times or a dot, but I usually use parentheses when it's times. So that's what my recursive sequence would look like. Let's write the explicit equation for this. So for this one right here, our explicit equation, you would say, all right, this is exponential. And if you remember, explicit, we had our starting value, and then we had our ratio here, what were we multiplying every time? So this is 3. And here we have to be careful because when I plug in a 1, I want to get 3. When I plug in a 2, I want to get a 9. When I plug in a 3, I want to get 27, and so on. So right here, this would be time here. Well, let's put X for time. Although this is hours. Yeah, so when I plug in hours, okay, this works. Yep, so if we try it right here, if we plug in a 0 for hours, let's put X here. When we plug in a 0, we get a 1. When we plug in a 1, we get a 3, and so on. So it works. Okay, so explicit equation, you have your starting value. Here we have our common ratio, and then here we have time. Okay, so we didn't look at the explicit equation yesterday. We looked more at the arithmetic, the slope and the y-intercept for an arithmetic equation to find the explicit. So today we're going to focus on geometric. All right, let's try another one. Example 2 on our table, we want to figure out, is this arithmetic or geometric? What's the recursive notation? And then find a certain value. Okay, so again, yesterday we focused on arithmetic. We're going to take a look at geometric right here. Okay, so first of all, is this arithmetic or geometric? Is there a common difference or common ratio? And if you don't know, a hint is you take any term and can you subtract the same number or can you divide? And so if you don't know, just pick one and subtract. So I know that 98 minus 49 is 49. 49 minus 24.5, that's not 49, so it's not arithmetic. So geometric, you just take one term and divide by the one before it. So 49 divided by 98, that's 0.5. Try it with 24.5 divided by 49, that's also 0.5. And 12.5 divided by 24.5 is also 0.5. So this is geometric. There's a common ratio here, and that ratio is multiplying. We're multiplying by 0.5 every time. All right, let's write the recursive notation. Our starting value, our first term in our sequence, is 98. To find any term in the sequence, we take the term before it and we multiply by 0.5. All right, let's write the explicit notation. So here we can say u sub n, which is like y equals. And we have 98 is our starting value. Our common ratio is 0.5. Now here, if I put to the n power, and again, this is one sequence, this is term 1, 2, 3, and 4. If I plug in a 1 here, do I get 98? And we don't. If we plug in a 1, we get 98 times 0.5, we get 49. So we have to be careful here, the starting value. Instead of n, we want n minus 1. And the reason for that is if I plug in a 1 minus 1, I get 0. Let me use a different color here to illustrate this. Okay, so when I plug in a 1, I want to get 98. So here we have 1 minus 1, and that's 0. 0.5 to the 0 power, that's a 1. And 1 times 98 is 98. Okay, so again, when I plug in u sub 1, this is what it looks like. U sub 1 equals 98 times 0.5. We have 1 minus 1 here, which is 0, and we get the 98. Okay, so here, it's a little bit tricky. We need that n minus 1 power if our first term is 98. Okay, so let's use that and let's find u sub 8 equals 98 times the 0.5 to the 8 minus 1 power. And so that's 7. In our calculator, we can type in 98.5 to the 7th power. Okay, so let me do that. Let's clear this. All right, so 98, and we have 0.5 to the 7th power, because it's like hitting enter 7 more times. So let me show you what that means. So here's our answer, 0.76. Here's another way to do it recursively. So we start at 98, hit enter, and then we're going to multiply by 0.5 every time. So the reason why it's to the 7th power is because since we're starting at 98, we're going to hit enter 7 more times. 1, 2, 3, 4, 5, 6, 7. And look, we get that 0.76. Okay, so again, since 98 is our first term, we're hitting enter 7 more times. So there's the n minus 1. And that's where this 7 comes from. And again, if it's the n minus 1 power, because we're starting with the first term, we're hitting enter 7 more times. All right, let's do a different one. And I did make a typo here, so let's change that. Let's cross off this 3. Okay, so now let's look at our sequence right here. And again, after looking at this, if you take any term and divide by the term before it, you'll find this is geometric. It's geometric. There's a common ratio. That's supposed to be a C here. Common ratio. And that common ratio is 1.5. All right, the recursive notation here, our starting value is 6. To find any term, you take the term before it and you multiply by 1.5. All right, the explicit notation, to find any term, we have the starting value of 1, which is 6. Our common ratio is 1.5. And since we do 6 and then enter in our calculator, this again is to the n minus 1 power. And again, I'll show you what that means. All right, so let's clear this. Doc B clears it. And we're going to start with 6 and hit enter, and then take our last answer and multiply by 1.5. So to find the 8th term, I would hit enter 7 times. So there's the n minus 1. So 1, 2, 3, 4, 5, 6, 7. All right, so we should get 102 for u sub 8. Okay, so again, we typed it in, and I hit enter 7 times, and we got our answer, which I forgot already. Oops. Let's go back to our calculator. Here it is. 102.516. So 102.516. All right, to do it with just the equation, let me change colors here. So u sub 8 equals 6 times 1.5 to the n minus 1 power. Again, we hit enter 7 times. So if we want to type that in, so 6 parentheses 1.5 to the power of 7, because you're hitting enter 7 times, and there we get the same answer. So you can choose to just type it in your calculator once or to hit enter 7 times, and you'll get the same answer. Okay, so let's practice a few more of these. For each sequence, determine if it's arithmetic or geometric. Write the recursive formula. This time find the 6th term. U sub 6 means the 6th term. All right, so this one right here, it looks like we're subtracting 2 every time. So this is arithmetic. All right, if it's arithmetic, let's write the recursive formula. So our starting value here is 109. To find any term, let me move this up here. To find any term, you take the term before it, and we are subtracting 2. And then to find the 6th term, a few ways you can do this. You can type this into your calculator and hit enter 5 more times. Or you can write the explicit notation, so I'm going to do that. All right, so right here, what is the y-intercept? Well, it's not 109, that's the first term. So if we go backwards and add 2, the y-intercept's 111. The slope is minus 2 to the n. So to find the 6th term, we take 111 minus 2 times 6. And if you do that, we're going to get 99, I believe. I'll show it to you on the calculator. So on the calculator, Doc B to clear. Oops. All right, so this one we start with 109. You hit enter, and then we're subtracting 2. So that was the first term, 2nd, 3rd, 4th, 5th, 6th. So you can do it a few different ways to get that. The 6th term is 99. All right, let's try the next one. So this one right here is not arithmetic. This is geometric. It's geometric. the common ratio, we're multiplying by 0.75. Again, to get that, take any number, divide by the one before it, and you should get the same thing every time. All right, the recursion right here. Whoops, I forgot that here. Okay, so it's geometric. The common ratio is 0.75. The first term is 200. To find any term, you take the term before it and multiply by 0.75. Okay, the explicit equation to find the sixth term, here's our first term, 200 times 0.75. And remember, we would hit enter 5 times for that, so this is to the n minus 1 power, and you would get your answer. Okay, so again, 2 ways to type it in your calculator, just straight out explicit equation. So here's what it looked like, 0.75 to the power of 5. Or we could type in 200, hit enter, multiply that by 0.75, and again that was the first term, second, third, fourth, fifth, sixth. So there's our answer, about 47.46. So u sub 6 equals about 47.416. Okay, so you can go ahead and try this then on your assignment. The goal is, can you identify arithmetic or geometric? Can you write the explicit for both and use it to find certain terms?